and welcome to what will potentially be a series of while the coffee is cooking or brewing. No theme music yet, and if you want to hear some theme music, go out to Professor Wild on trigonometry or some of the other great math sites. But this is going to be devoted here to some engineering and some what we've got to be able to do here to make sure that we can do some of this stuff relatively one-off envelope calculations in terms of alignment design or corridor design. So I'm going to sketch in right here a topo map, a pretty simple one, and we're going to make these 2-foot contours, and we're going to try to remember the kind of things we learned in drafting class or whatever else, that every sketch should have a north arrow. It should have some relative scale, so I'm going to try to do this like you would do in CAD. I'll make that distance, right? We'll say this is about 1 inch equals 40 feet. And I'm going to guess that this is about 1 inch, right there. North, up. Remember, our standard scales have to be read on an engineering scale: 1 to 10, 1 to 20, 1 to 30, 1 to 40, 1 to 50, 1 to 60. Nothing else up to 100, up to 200, up to 300, 400, 500, 600. Has to be read on an engineering scale. 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6. Must be read on an engineering scale. You get the shtick. Alright, so you've got it plotted to a standard scale. You might be a standard scale. Sometimes you might be working on a map where it's not a typical standard scale, but I think this is. USGS 7.5 minute quadrangle map is 1 to 24,000. 1 to 24,000. Remember, that means 1 to 2,000 feet. A lot of this stuff is done on a large scale. So remember the difference between a scale, like an engineering type scale we talk about in civil, 1 inch equals 10 feet, and a real scale, which is always this. It's always distance to distance. Meters to meters, inches to inches. So this means 1 inch on the map equals 24,000 inches on the planet. Alright, we got your north arrow. You also, of course, want to have your datum. Your vertical datum is NGVD, typically 88, sometimes 27. And your horizontal datum is usually something like the 83 NVD, it's 83. NAD, sorry, NAD 83, or the Harn. And finally, you very often have the coordinate system, which ties into one of these two things as well, and we use the state plane. Now, many of these things, they're implied. But let's not make them implied. This is not implied. You must do it. Alright, you have your topography map. Switch colors here. Put some things in a redder. I guess in a blue or thing. Alright, what I'm going to do is I'm going to put, perhaps you want to go through here. This is something you want to hit. This is the start. This is the finish. And maybe this is what you want to avoid. Right? You want to avoid, I'll call these trees. I'm going to call them nice trees. And maybe over here on this side, right here, and right here, might be a wetland. A wetland. So in an alignment design, you have to pick what you're going to avoid as much as what you're going to hit. And you generally have a goal to go from one place to the other. Your next step, typically, I will say in Civil 3D or anything else, is to draw straight alignments through. Not straight from here to here, but you're going to be drawing your plan in tangents and ignoring the curves, doing the curves next. See if I can put this in black, which I can't. So I'm going to see if I can then put this in purple. How's that? Figure out these colors later. And what you're going to do is you're going to take out a straight edge, which I don't necessarily have working on this right now, but I'm going to try it. The one bad thing about Smooth Draw is that it does not have a straight edge function. All right, I'm going to go there. Even though my PC is going to be here, I'm going to draft these things that way. Well, screwed up. Alright, so I'm going to put away the straight edge with this tool and I'm going to sketch it in. What you're doing is you're drawing straight edges. You're drawing straight runs. Straight runs. You're not doing the curves typically when you do this stuff. I'm going to do this here. And I'm going to go here. I'm going to introduce you to the fact that when you run out of data, typically you don't move your road because you ran out of data. You get more data. Another tool I don't know how to do now is how to add that line out here. So once you've done this, you lay out your horizontal. You now have a PI, a PI, a PI, a PI, and a PI. Point of intersection, horizontal point of intersection. You can realistically, when you're learning the horizontal curve calculations, you can come back and actually figure out your radius is what you want and sketch in your curves here relatively close per se. And you have now a PC, a PT, a PC, a PT, a point of curvature, a point of tangency, a point of curvature, a point of tangency. Right, you have each of these. You now have basically your horizontal alignment relatively figured out, and you're going to usually go with engineering on a computer on this, so you're not going to overly worry about where these things are at because they're going to be adjusted in a design. We lay this out, and realistically, as we're playing on a computer, we'll lock this horizontal design pretty early in a design. Alright, so these, of course, you know the curve calculations and the like. The next thing you do, probably a different color, is you go ahead and mark up your standard major ticks, and I'm going to do this with my thumb. You can use your thumb for this, but you should probably be able to do a little. There's 100. You got a tick there. You always get the PC. You get its distance. You know what the PC, what that station is. You go to here, 200, perhaps 300. You got the PT, perhaps 400, 500. You're marking these up here, here, and here. You typically can mark, so you pick a starting station. You'll see that you want your starting stations to not overlap. If you have two alignments, if in the end we're going to do another alignment down here, from here to here, with a PI and a PI. You do not want your numbering to PI and PI. You do not want your numbering to overlap. So you maybe begin this one at 10 plus 0, 0, and you mark up. It's like this is based on our scale. This is 11 plus 0, 0. This might be 12 plus 0, 0. This might be 13 plus 0, 0. And this might be 14 plus 0, 0. You will see you're very soon to be able to actually do the calculations on these curves, so you don't have to kind of go through and do something we call station equations. Alright, again, in class you did a straight alignment. This is a little bit more difficult, but you'll see when you get to using the numbers, it should not be that bad. The next step is either in a table format, but probably just right here, you go ahead and you write up the existing grade on each of these. You write up the existing grade. I'm going to put the existing grade in green. It's usually a lighter color, and it's usually off in some angle. So basically right here you're going to have something here, and I see if I can do it. Existing GRD, And very often what you'll do is you'll put the proposed grade, proposed. So you can read one this way and one proposed grade, proposed elevation, whatever you're going to call it. You're going to go ahead and I'll go ahead and do that here. We said like maybe this was 100 elevation. We'll make this 98. We'll make this 96. We'll make this 94. You go ahead and mark them up. So this one turns out to be about a little bit more than 96. These are usually put down, the existing ones are put to half an accuracy of 0.5. So this might be something like 96. This one here might be somewhere around 100. This one here might be something like 98. This one here might be something like 94, etc. You're then going to think, you're not always going to do straight grades, you're going to think of what you want to do for your proposed. So let's see if I can go back to the green. So maybe you're going to think about what your vertical constraints. So maybe you want to cut this hill down, or you want to go straight from here to here, or maybe you want to go higher. But you're going to mark up your vertical constraints. So right here you might mark this up and say, I want to be at 96. Alright, and maybe here I want to be up at 102, going against the grain. So you're going to mark these things up and come up with some proposed grades. That leads to what you had in class, which looks something like this. I'll fit it on this. You have station, existing, there's the coffee. I'm going to stop this, pause it, and do a little bit better job next time in getting it done before the coffee burns the house. Hang on. I got to put less water in the pot. Alright, you have something that looks like station, existing elevation, proposed elevation, and then cut and fill. So here 10 plus 0, 0, 11 plus 0, 0, 12 plus 0, 0, 13 plus 0, 0, 14 plus 0, 0, 15 plus 0, 0. You get your existing elevation, you get your proposed elevation, and then you have your cuts or fills. Alright, so there's one sketch. I'm actually going to save it. I'll be doing this on the board one time at school today to see how it captures with me dancing around. I'm going to go File, Save As. I'm just going to say on my desktop 1. And of course, you know it, I know it. I'm just going to hit cancel here because I forgot to turn on my keyboard. Alright, the last thing that you need, and was probably the first thing you needed to do, and we'll talk about where we're going to put this, but way down over here on the plane, we should have come up with some sort of sketch which shows our proposed cross-section, our typical cross-section. That's going to be called an assembly in Civil 3D, but something that shows, like here, this is 10 feet. It should show your center line or reference line, and this is 1 to 1, horizontal to vertical. You know, H to V, horizontal to vertical, is 1 to 1. That is the place that follows along this alignment here. So the steps. Have a topographic map, or some map at a standard engineering scale, hopefully. Standard engineering scale can be read on a standard engineering scale. Know your datum, know your coordinate systems. Put in your horizontal constraints, what you need to keep and lose. Draft straight tangents. Put in your curves, guessing if nothing else. And we'll be looking, that's what the highway survey class is about. Put in your major stations. Put the elevation on your major stations. Guess at what your proposed elevations will be. Make a table. And finally make sure that you have some idea to start of what your most likely proposed cross-section looks like. Thanks for listening. Time for coffee.